Hello, mathematical lovelies. Welcome to our first lesson on dealing with matrices. Now, it is quite possible you have seen matrices before. That being said, the structure behind this will hopefully help you out a little bit in understanding them a little bit better. And the goal is to learn some basics about them today, and then we're going to get to more interesting problems as we go forward into our second day of matrices. So this is notes for day one. And then day two will be the next video. Sorry for that early pause. I accidentally hit a button because that's what happens when I start doing stuff. So we're going to go through elementary operations with matrices today, some of which will be very simple and some will be possibly new depending on what your background looks like. So that's where we're at. A couple things I want to say along with this is to be careful with your addition, subtraction, multiplication with this because that's what operations are. They're very basic, but it's very easy to accidentally do something you don't want to. At the same time, I'm also going to create a second video where I go through and do all of these operations with technology. The goal being that, in my opinion, no one does these by hand anymore. So the goal is that by seeing how to do it by hand, you understand how it all works together. But then when you're using it in practice, you will simply use the item I'm going to show you from the internet today. So that item in particular is a website. It's also an app. I don't want you to pay for the app because honestly, you can get everything you need out of it for free, so don't feel obligated to do that. Normally, if we were in class, I would teach you all how to do it on your calculator, but since we're not, we're going to be utilizing the internet to help us do some things. So let's look at a leading example to help us understand what a matrix does and how they operate together. So, Amazing Baked Goods sells plant-based cookies and brownies. Now I want dessert. The table below summarizes the cups of ingredients required to make each batch. Please do not try to make these. It will definitely not work. I made up these numbers. There are two suppliers from whom the bakery can purchase ingredients, Artie's and Birdie's. This was literally A and B originally, and cookies were C and B. And then I was like, what can you name that's a dessert that starts with D? And then it changed to brownies. Why am I telling you guys this? Because I'm alone. Let's create a table that displays the total cost for each baked good based on this. So there's a bad assumption we're making with this in that when I'm making cookies, I can only buy all of my ingredients from one supplier. Because hopefully you enterprising business students look at this and you're like, well, I need to buy my flour and my sugar from Birdie's, Artie's, because those are both cheaper, and then I'll just buy my vegetable oil from Birdie's. But we're going to pretend you can't do that. You can only go with one supplier for each of these, which is totally not true because I made up this example, and that's where we're at. So if we were trying to organize what's actually happening here, there's two things we got going. We got cookies, which I'm about to misspell, and brownies. And then we have two suppliers, Artie and Birdie. Okay. Terrible handwriting is already showing, so this is going real well. Anyway, so if we were to make cookies, which requires 2.5 cups of flour, like 2/3 of a cup of sugar, and 2/3 a cup of vegetable oil, at Artie's that'll cost us respectively 10 cents, 21 cents, and then 0.46 or 46 cents per cup. So at Artie's, to make a cookie will cost you 2.5 times the price. So that's the 2.5 cups of flour times the price of flour. Again, please don't try to make these. Plus how much you need times how much it costs. Plus how much you need times how much it costs. And then I really wanted this to actually all fit in one line. So I'm going to move. Nope. Didn't mean to do that. I'm going to pause for a second and try to grab this instead of using the pen. Will it let me? Probably not. Yeah, okay. And then similarly, we got to buy the same amount at Birdie's. Let's just do this, even though I don't want to. 2.5, but it'll cost us a different amount, 0.15. My fives are looking real awesome already. Same thing with sugar, costs us a different amount. Make it work. I believe in us. Going right off the page. Cool. And then if we go to do brownies, it's a different amount of flour needed for the same price at Artie's. Different amount of sugar needed for the same price at Brownies. Different amount of, what am I on, veggie oil? Yeah, veggie oil needed. Oh yeah. And then it's going to be the same first values, but different second values. So 2.15 times 0.15, 0.67 times, how much do I need now? No, wait. I don't need 0.67. I need 2 because I'm making the brownies this time, not the cookies. Sorry about that. I should have made them all easier numbers, but that wouldn't be very realistic, would it? 40 cents. I've screwed up here. This is 46 cents at Artie's. Oops. Gotta make sure it's right, or else you do it wrong. Okay. Now, I have taken the liberty of calculating all of these already. So if you want, you can pull out your calculator and double check me, which is always fun to do, right? So I'm going to write these in here. 39. I almost wrote the wrong number. Then I would totally got an email from you guys like, are you sure you know how to add? Yes. Am I sure I know how to write? No. Haha, that was supposed to be funny. Okay. So, if you had to only get your specific baked good from one supplier, you should look at this and be like, okay, I should get my brownie supplies from Artie and my cookie supply from Birdie. But wait, there's more. If you look at these combined, you probably will change your mind, right? Maybe. I don't know. This is a little strange and a kind of a silly example, but you get the idea of how, like, combining these two organizational ideas can help you organize into a third idea. Good times, because we just made some matrices. Anyway, so the definition of a matrix is a little bit strange. I'm going to write it and then write the notation that goes with it so you can see how it works. So basically, a matrix is an ordered array. If you've never heard, oops, I missed the R in that, and another E. Arrays are just ordered lists and they can be any size. So we say this will have M rows. I am having the hardest time writing today. And N columns. Okay. So how we'll write this symbolically is we'll write A. Usually it's just any capital letter like A or M is, and then we'll use lowercase letters A, I, and this is a subscript A, I, J. They're both in the same sub with our I between 1 and M because that's our number of rows. So the first one is going to correspond to rows, and then the second one is going to correspond to columns. Okay, so the little a ij's are called entries. And and we'd say that A has size, or the size of A is M by N. So there's that by symbol with a cross, just so you know. So when you're looking at this, for instance, if I had the first item we looked at where I was comparing ingredients to cookies, we'll call that the I don't know, we'll call it B for baking requirements for Artie's. We'd be like, okay, the first entry would be my flour cookie entry, which I need 2.5 cups for. The second entry, I shouldn't call that first entry. My entry in the first row, first column will be 2.5. My entry in the first row, second column will be 0.67. I'm hoping you're seeing where this comes from at the top. And then my third entry in the first row would be 0.67 as well. And then my first entry in the second column, which it's hard to remember to say that correctly because I'm used to saying, oh, that's in 2, 1, because it's in the second row in the first column. 2 and then 1. So this is an example of a matrix. So for instance, the entry 1, 3 would be in the first row, this row. In the third column, that would be 0.067. Since there's 2 of those, let's go ahead and describe this last entry because there's only one in here, one in here. And so that would be in entry, well, it's in the second row, but in the third column. So that would be entry 2, 3, which hopefully you notice is not equal to entry 3, 2, because 3, 2 doesn't exist. There is no third row, second column. Hope that helped you organize your thoughts on how these all get arranged. It's a little strange. So the object you're describing would be a matrix. Here's some entries, and this one we would describe B as being, well, it has 3 columns and 2 rows, so this would be a 2 by 3. Sounds like I'm going to do some lumber. Let's talk about some basic operations. So we're going to talk about addition and subtraction, which you know how to do for single value numbers. We're going to be doing this for matrices. Alrighty, I need to scroll this up and make room. Alright, so addition and subtraction of matrices is done what we call entry-wise. So suppose we have let A, ooh, I missed the T on let, and B, B matrices. And this is going to be very, it's hard to spell matrices, just so we're clear. Actually, I'm going to pause and make sure I'm spelling this right. I am proud to announce that, okay, Latin has fooled me again. No IE. Matrices. C's. It's got ices. That doesn't help me. Okay, I got 2 matrices of the same size. They have to be the same size to do this. Same size. So same number of rows and columns. Okay. Then if I want to do A plus B and make a new matrix, or A minus B and make a new matrix, how you're going to do that is you're just going to take a little Aij and add little Bij. And you're going to take little Aij and you're going to subtract little Bij. And that's it. You just subtract or add their entries. So if that seems like you're reading symbolic tomfoolery nonsense, let's go through and do a couple, because it does seem like I'm just insane. I'm going to write out more detail for these than you need to. I know in my heart of hearts you know how to add, okay? This should not be anything that scares you to death. So how do I make this new matrix? Well, I just do them entry by entry. So I usually go down a row and then go down a column. So I'm going to take my first row, first column, add the first row, first column to it, and that's going to be the first row, first column in the new matrix. Same thing, my first row, second column, I almost did the wrong one, and then add, watching my signs, the first row, second column, the other matrix to make my new first row, second column. I'm sick of saying that already. So when I look at 2, 1, I'll add the 1 from 2, 1. 0 plus 7. When I go to 2, 2, I'm going to add the 2, 2 to make the new 2, 2. That was much funner to say. Okay, and now let's do our additions. Yay, showing work. So 1 plus 2 is 3. 0 plus 7 is 7. This is the other thing. It's like I'm trying to force myself to go across. I usually go down. 5 minus 3 is 2. And then 1 minus 1, 0. Okay, there we go. There's our new matrix. That's it. Done. That's how you add. Let's keep going. So I'm hoping you notice that this first matrix is a 1 by 3, and the second one is a 3 by 2, which means you cannot do this. Cannot be done. They are not the same size. I make sure I include why. And that's why. So you can't do this. That was an easy problem, right? Done. Okay. Now to mess things up, I've got something a little wilder. So hopefully you remember your order of operations and know that multiplication comes before addition and subtraction. So what I'm going to do here is I'm going to take everything and multiply it by 2, and then I'm going to subtract. So I'm not going to touch that first matrix. It's going to come along with us. And then minus, and then I'm going to multiply everybody by 2. 2, 0, 10, negative 2. All right, let's do our subtraction step. 2 minus 2. Minus 3 minus 10, 7 minus nothing, and then 1 minus a negative 2. Watch your signs. Let's be careful. I think that like the temptation in this homework is going to be like, I got this. I'm going to go real fast, and then you'll have like little hiccups happen. You know what I mean. Okay. On to the next phase. Now, this is the more difficult operation. So addition, subtraction was easy. Matrix multiplication is a little bit more hairy. It's a little bit more involved. I've already actually done a matrix multiplication for you. That was the first example I did with the cookies and the brownies and Arties and Birdies. I actually did what matrix multiplication looks like. So if you think back to that example, how I was doing a combination of multiplication and addition, that's exactly what is going to happen here. So I'm going to write this out in the formal mathematics behind it, then we're going to do some, and hopefully by doing some you'll feel a little bit more comfortable because, what am I trying to say? When we start doing them, it makes more sense what the math was behind it. So we're going to have A, B, little aij, like I have been doing. That's supposed to be an I. J. B, m by n, and we're going to have another matrix B, B little bij's, B, A, and this is very important, n by k, so it's different size. So when we go to multiply, we're going to get A times B is going to be a new matrix, Cij, and I'm going to tell you how to get the Cij's. A n by k matrix. And I want to change colors really quickly because I'm going to write something on the side. So, little note to the side, when I take an m by n and multiply it by an n by k, the result will be the following. So what's going to happen is the check is these have to be the same. Very important. Have to be the same to do this. And then what you'll get as a result will be the outer ones. So you're going to take m and k, and boom, that's going to make your new matrix. It's going to be an m by k. Okay? That sounds like crazy. But that's exactly what's going to happen. So how this is done is you're going to take the rows in A times the columns in B and then add up all the entries resulting from those multiplications. Yep. Does that make sense? If not, here is the formula behind that, and I'm going to write the description of it. So the little Cij's are going to be AI1 times B1j plus AI2 times B2j plus dot 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 until you hit the last one, which will be the nth one, AIN times BNJ, or if you want symbolically, it's AIK times, I really shouldn't use K because K's already been used. What letter have I not used yet? Crap. I can't use X, it's a variable. HIJK. L? Oh, L's look terrible. M and N have already been used. P! There we go. Oh, then I've got like PBJ. That's fun. And completely unintentional. Where our little p is going to go from 1 to n. So it just goes down the whole row. Yep. So as I describe this, I go down the row of A, and notice I'm moving in the columns because this is row, column. I'm using in the columns for B. So you take row of A times a column of B, and this is why the rows and columns, that middle part has to match. Oops, I didn't do the of B. This was supposed to be a capital A. And then add together all the multiplying. Woohoo! Which seems weird. This is my description of what's going to happen. Okay, let's look at doing some because reading how to do it is very different from seeing how to do it, as I've already described. Hopefully this goes smoother than I think it will. Let's find out. All right, so I'm going to start out pretty basic. So I want to keep this description on here. Oops, I meant to erase that. So here I've got what we've seen before. I've got one row with 3 columns, and here I've got 3, oh, no, wait, row, column. How many rows do I have? 1, 2, 3. Oh, I do have 3. Why did I think that was wrong? I don't know. By 2. So the result for this is going to be a 1 by 2. And I can do this because these two are the same. The inner sizes match. Okay, so how we write this is we go across the row and down the column. And this is going to make our first entry. This is going to look kind of weird. I hope you're okay. So I got to do 1 times -1 plus -1 times 2. And then the next one, 2 times 0. And that's our first one. All right, so as you think about this, row 1 times column 1 makes 1, 1. So in making our next entry, row 1 times column 2 will make row 1, column 2. So I'm going to go down this column. So 1 times 2, so see how this second entry is going to change, plus -1 times -1, and then 2 times 5. And you know how I said an add them all up thing? Like I'm writing it as I go. All right, let's make a little more space so I can write the answer to this. Hopefully you're following along okay. So let's see, -1. So -1 times 1, that'll be -1. -1 times 2 will be -2. And then plus, well, that'll be 0. So I'm going to get a -3 for this first entry. And then for my next entry, I'll get a 2 plus a 1 plus a 10. So that better be 13. So there's my matrix. Now, yeah, that's it. I hate how this looks. Just as a little warning, there is some other notations for how these look. I've also seen them like written with parentheses. I can't remember if your book does that in any place at all, but it doesn't mean anything different. It's still a matrix. I actually don't like this because it looks a lot like a point, or it also might look like, what's the other thing that looks like this? Intervals. So I like the square brackets better because, you know, it makes it a little easier to tell that it's a matrix and not one of those other objects. Let's do another one. Let's do blue. I've done a lot of red and orange lately. A little more eye-catching. If you're colorblind, I'm sorry. Okay, so here I have a 2 by 2 times another 2 by 2. Yay! So this will be nice and easy. The insides match. So my number of columns in one matches the number of rows in the other. That means the result will be their outer values, which means my result is going to be a 2 by 2. All right. So to get the first entry, I need the first row times the first column. I wrote that in a terrible spot. So I'm going, I actually like using the highlighter for this. First row, first column. Let's get this done. Okay, so my first entry will be 1 times 2 plus 5 times 7. Second entry, erase the highlighter. Now I'm going down this way. So I need 1 times -3 plus 5 times 1. Looking good. Let's make the rest of this. All right, now let's go down this second row and then first column to make the entry in the second row first column. So 0 times 2 plus -1 times 7. And then over here I'm going to do 2, 2. So 0 times -3 plus -1 times 7. I am going to run out of space. So let's make sure I write this not crazy. I made that huge. So 2 and 35 should make 37. And then here I have 5 and a -3, so that's a 2. That's nothing. -7. And then here, ooh, lots of negatives. It can be a -10. Look at that. That's pretty good. I like it. It's a interesting one. I don't know. Ooh, I'm going to go the other way. Now, something to notice when you're comparing B and C is that on this one, I seem to have flip-flopped my matrices, yeah? So like the one that was second in the part B is now first in part C. So what's interesting is what we're going to see is if we call this A times B, I'm now going to be doing B times A. And you're real used to if I do like 3 times 5, it'll be the same as doing 5 times 3. But you're about to see it doesn't work for matrices all the time, is what I'm about to show you. Matrix multiplication, it actually matters what order you're in sometimes. And I will emphasize this sometimes. Let me do this in a different color, but a close color because they're very similar. Let's do this purple. Purple is always very lovely on this. Okay, so let's see. I'm going to use less space this time. I'm going to be more careful. Let's see, down this row, down this column. The drawing arrows on there really helps me understand my order of operations here so that I don't screw it up. If you don't like it, you don't have to use it. It's just how I like to do. You got pencil, so you know if you screw up, it's always okay. You can always just go back and change it. Make sure you got your order right, yo. Hopefully you're following along with me because you're kind of getting what's happening. I hope. That's my dearest dream, that as I talk to the space of nothing, that someone understands. I'm narrating less this time, not minus plus. Boo, 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 boo. 7, 5, 1, -1. So one thing I usually like to check to make sure I've done this right is that like I have things in the right position. So here I flip things around. This should be 1, 0. it comes, it's how I know this is wrong. So this should be 1, 0, 1, row, column. I almost screwed that up. So these 1 should be the same, these 0 should be the same, these 5 should be the same, these negative 1 should be the same. And then 5, 1, 5, 1, 2, negative 3, 2, negative 3. I almost made a mistake. Almost. But I checked myself before I wrecked myself. By keeping my order always the same, I can do that. All right, so 2, nothing. 2, 7, nothing. 7! That was kind of fun. All right, 10 plus 3. Or plus, yeah, plus 3. 13. I almost called it 14. All right, 35 again. 1. Oh, minus 1. Be careful. 34. Aha. So it has a lot of the same entries, but it's not in the same order. So one thing worth noting is although these have the same entries, they are not equal. So this is a very important observation. When it comes to matrix multiplication, it doesn't do what we call association. So A times B is absolutely 100% not equal to B times A, except for in the special case when one of them is a special matrix that we're about to see. I like special. Speaking of special, let's up our game into a 3x3. I've been not looking forward to this one all day. I knew I was going to do a big one. I should have put this one last so I had more space. But as usual, I've made poor choices. I almost feel like I'm a Victorian woman about to pull on someone's, what's that thing? Corset. Brace yourself. That's the worst joke I've made all semester. I hate myself for having said that. Let's do this. So down a row, down a column, across a row, down a column. Oof. So I'm hoping you notice the frequency of zeros in here. So because of that, we're going to have lots of zeros that happening. So 12 times a 1, and then everybody else's times a 0, so I'm just going to do this to save myself some space. I am only going to do this where I see zeros, okay? Alright, next one up. So, here we go. Oh, I didn't do my usual. Can I even do this? 3 by 3, it's square. Oh, I haven't told you what that is yet. Times a 3 by 3 is going to result in a 3 by 3, and it will because these match. So we're going to have a 3 by 3. Good times. All right, first row, second column. So where do I have a 1 in the first entry? So I'm going to get a negative 3 times a 1, and then 2 zeros, which I really shouldn't even bother writing, but I'm going to do it anyway just for consistency. And then down to our last column. Let's do this. So I get a 50 times a 1 plus a whole lot of nothing. Woohoo! Just made it fit. Just make it fit. It'd be fine. I'm way too dramatic today. I probably shouldn't be in charge of anything. All right, let's do the next one. So we're going to go down row 2. I'm highlighting because it's kind of hard to draw the arrows inside. All right, here we go. So 12 will be times a 0, so the first one's a 0. And the second one will be times a 3, so I'll have the 3 times a 1. And the third one's a 0. I spaced this one too much, so now it's going to stick up next to the next one, which doesn't make me happy. So first entry 0, second entry will be 1 times a 2 plus a nothing. Hopefully you're looking at me like, gosh, woman, why are you writing times 1 when you really don't have to be? You know what that's going to do, because I'm being facetious, okay? I'm being dramatic today. We're going to live with my choices. You don't have to live with my choices. You can write what you want to write. Okay, nothing times a 1 times a nothing. So nothing plus 1 times 1, very silly, plus nothing. Okay, this has been a long journey. I hope you're enjoying yourself. Let's do this last one. So I'm going to get nothing, nothing, and then a 9. All right. Nothing, nothing, and then a 2. My lovebirds are being super loud. I'm assuming you guys can hear them. And then nothing, nothing, and then an 18. It's funny, when it's just one of them that's making noise, I can really tell them apart. But most of the time I can't because I have 2. But right now I can really tell it's Link. Okay. So 12, nothing, nothing. 12. 3 and nothing, 3. Nothing, nothing, and a 9 because it's 9 times 1. Everything in here is multiplying by 1 or 0 because that's what the original first matrix was. So negative 3, nothing, 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 2, nothing, 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 2. What is this madness that we see? It's not special, it's something. Well, it is something special. I shouldn't have said not special. It's 100% special. Make that a little bigger. 50. No, I don't want to change my stuff. Sorry, 50. And then nothing, 1, nothing. 0, 0, 18. Oh my gosh, I got back what I started with. Well, one of them. So I just got this matrix back. I wonder if this one is special. Special! Oh. Okay, it is special. I'm going to skip E and come back to it because I want to get this definition down of what just happened because it seemed kind of magical, didn't it? Woohoo! So, an identity matrix. So this is a square, n by n matrix, and we call it usually I with just one n at the bottom to give you its size. With ones on the diagonal and zeros everywhere else. Is it? And elsewhere, because we want to sound as formal and fancy as possible. Now, just to give you an idea what this looks like, so like I2 will be 1, 1, 0, 0, bam. We just saw I3, which was 1, 1, 1, bunch of zeros. Oops, I forgot to draw the boundaries. There is I1, which is hilarious looking because it's just a 1 because there's just the diagonal. And then the one thing that's very special and important about an identity matrix is anytime you multiply a square matrix by it, you'll get itself back. So if I do A, oops, sorry. I need something that's square first. Let A be n by n. Then if I take n, in times a, I'll just get a back. And I get the same thing if I multiply on the other side, which is just what we saw. We took the identity times a matrix, we ended up with the matrix back. And that's why it's called an identity. It behaves like a 1. It just gives you back what you started with. Identities are important because they're going to help us find these guys, inverse matrices, which I'm going to talk about after I go back and do E. I definitely put this in the wrong order. Should have did things better. Regrets. Just a bad tattoo. To the internet. Okay. Let's multiply this last one and we should be good. So we have a 2 by 2 times a 2 by 2, which means these match, so we're good. Check, check. And the result will also be a 2 by 2. I'm hoping you notice that these ones that are the same number of rows and columns are more common because they totally are. They help us solve stuff is what we're going to see later. So let's get this party started. Row, column. So 3 times 2 plus 1 times minus 5. You almost can't read that negative 5 because of how I drew that. All right. And then down this row, so now I get 3 times negative 1 plus 1 times 3. Oops. Wrong parenthesis. All right, next row. Bloop, bloop, bloop. 5 times 2 plus 2 times negative 5. And then 5 times 2 times 3 and negative 1. So 5 times negative 1 plus 2 times 3. I did it again. Oops. And then I wrote one terrible. Okay. I think we're done with squares. Here we go. So 3 times 2 is 6. Minus 5 will just give me a 1. 5 times 2 is 10. Minus 5 times negative 2, which is negative 10, so that's nothing. Uh-oh. 3 times negative 1 plus 1 times 3. Negative 3 plus 3 is nothing. Why did I write this so far over? Don't ask me. It's that kind of day. 5 times negative 1 will be negative 5, plus 2 times 3 is also 6, so this is going to add to be 1. Oh, look, it's I2. See why I saved this? So it is special when you multiply two matrices and get I, because I behaves like 1. So this is like I multiplied two things together and got 1. Interesting. When does that happen? Well, when you have something called an inverse. So hopefully you remember inverses from inverse functions. If you don't, that's okay. Let's talk about what a matrix inverse is. So we will do A with a little negative 1 to be the inverse of a square matrix A. P.S. You can only do this to squares. a n by n matrix. I should have written that first. Oh well, too late now. Anyway, we'll write this if, when I do A inverse times A, I get IN, and the same thing with the other side. So if I do A times A inverse. So one thing I want you to note is it has to work on both sides since the multiplications aren't necessarily the same. Remember, A times B isn't B times A this time. So you have to have like both of these work. So need to have both multiplications work. BIN. So I've only done one in E. I've only did one side, so I really need to do the other side to check. It does work. Don't worry about it so much for that one. And then the other thing is that this is only doable for square matrices. So only ones that are the same rows and same columns. Only possible for n by n matrices. And I'm spelling it wrong again. Want to put that I in there every time. Anyway, because of how it sounds, matrices. I guess it doesn't really sound like it has an I in it. Okay. I mean an I right here. That's what I'm always tempted to do for some reason. Yep. So these are called square. Or invertible, because you can flip them around and do inverses. Okay, so what I need to teach you now is how to find an inverse. So this is a little bit of a process, and it's not the easiest thing to do, just so you know. And it's going to seem a little crazy. Oh, sorry, I scrolled too far. Okay, so in order to do inverse matrices, we're going to need to take a little interlude into what are called elementary row operations. So these are going to be like the moves you're allowed to do when it comes to, you know, solving stuff. So when I say finding an inverse, we're really kind of doing the steps behind doing a solution. So we're going to have the following elementary moves. I shouldn't call them that. I should call them their actual name, row operations. So the idea is that when we do these, we're going to only do them to one row of the matrix, and we're going to identify the rows by R and then a little sub 1. So like, let little RA be the ith row. So for instance, here is one of our first moves we can do. We can add 2 rows and replace. One of the rows. I should say one of those rows. You can't replace the third row. So if I take row 1 and add it to row 2, I can write that on top of either row 1 or row 2, but not both. You're going to see me do these. This one's my favorite one to use. You can also multiply by a constant, but it's got to be non-zero. So for instance, I could do 1/4 of row 3 and write that on row 3. And then the last move, and this one I don't use as much, you can exchange 2 rows. So usually I write this as, let's switch row 1 for row 3. Get the idea? You can also combine moves 2 and 1 together. So that will look like, hey, I'm going to do row 1 minus 2 times row 3 and put it on row 1. And this is the more popular move. Highlight and stuff. So how do I use that to find matrix inverses? So what we do is we take A and augment it with an inverse. And then you do row operations until you end up with the inverse on the other side. And then this matrix B is your inverse. This is symbolically what I am going to do, and it's going to seem like crazy. but it works. Also, the matrix calculator I'm going to give you that has a link along with these notes, and I will have the example notes to go with. It just does this in one step. So if you find this absolutely terrifying, don't worry so much. Let's find the inverse if it, I like words when they come out of my mouth correctly. Find the inverse if it exists. So I've only got 2x2s here. This should go pretty well. Let's get this party started. So the first thing I have to do is augment this with our inverse, or sorry, our identity. So we're going to rewrite it 1302 line within identity 1001. So that's my first move. And now I need to make it so this has a bunch of ones and zeros on this side. And if you look at my first column, that looks really good. 1 0 looks good. This one I need to change up into a 0 1. So when it comes to strategy with these, think about a kind of like a backwards N. You want to do it like this. Make this one work first, and then that, and then that. I know that sounds crazy looking, but that's the order you got to do it in. So if this was like a path, you're like, I want to work my way down the first column, then across the diagonal, and then to this entry, and then back down. It looks like I'm drawing one of those crazy diagrams in football that tell people how to like hit each other with stuff. So because of the first row being fine, and you're going to see me do this full strategy in B, so don't be too scared. I just want to have an easier one first off. I'm going to focus on getting rid of the 3 here. So I want to make this 0. So how do I do that? I'm going to use row 2. So I'm going to take row 1 and combine it with row 2 in a very specific way, so that when I write it on row 1, I end up with a 0 in that entry. So what I want to do is I want to have these two cancel each other. So I'm going to double row 1 and minus 3 times row 2. Because when I do 2 times 3 and add to it negative 3 times 2, I will get 0. So let's see how this works. So remember, I'm doing double the first row and then negative 3 times the second row. So doubling 1 minus 3 times 0 will just give me a 2. Let me go ahead and write in the second row since I'm not touching that one. There we go. So I don't accidentally do anything to it. And then I do 2 times 3 minus 3 times 2. Those are the same, so that's going to be 0. 3 times 1 minus 3 times, 0, so that's going to be 2. And then 2 times nothing minus 3 times 1, when I add it to nothing, will give me negative 3. So hopefully you see how I got that. And now I'm looking pretty good because I almost have what I want, except for my diagonal is no longer a bunch of 1s. So my next move is going to be just multiplying by a constant that'll fix that. So on row 1, I'm going to multiply by a half and write it on row 1. And I'm going to do the same thing to row 2. And that will yield exactly what I need. So 1, 0, 0, 1. Because I'm dividing everything by 2, dividing everything by 2. I suggest you always do this last. There are some textbooks, when you read them for strategy, will start doing this in the middle. I always do it last because then I don't have to worry so much about like things getting all crazy fractiony until the end. So divide by 2 will give me 1, and I'll get a negative 3 halves here. Divide by 2, 1 half. So what this tells me is my inverse is just that second matrix. So negative 3 halves, 0, and 1 half. I'm hoping you see a pattern as to what's happening here, because it turns out that 2x2s actually have a nice pattern, 3x3s not so much. Because notice there's a lot of the original values that were in there still here. I wonder what's happening. Okay, let's do this next one. This one's going to be more involved. First step, let's augment. Oops, not 0. 1's on the diagonal, 0's everywhere else. So the first thing I am going to be getting rid of is that negative 4. I want to make that a 0. Always start there. So my first move that I'm going to make, and I'm trying to change colors so you can see where the moves happen, is I'm going to combine it with the first row to make my 4 go away. So I got to do 4 times row 1 plus 7 times row 2. This one's going to get huge quickly onto row 2. Since I'm not touching the first row, I'm going to go ahead and write it in. I always do this usually when I remember to, because like then you don't accidentally write on a row you don't want to. Okay, cool. Let's figure out what this second row would be. If you want to, some people like to write their numbers out in front so that they know what they're multiplying by and they don't make a mistake. If one of them's negative, you can write a little negative there to kind of help yourself out. This is not proper notation wise, but you know, just to give you an idea. 7 times 4 minus 4 times 7, that's going to give me a big fat 0. That's a good thing. We'll do 4 times negative 3, and that will give us a negative 12. And then 7 times 2 will give us a 14. 14 minus 12 is going to give us a 2. And here's where it's going to get a little wild. So nothing, and then a 4. And then a 7. Looking good? All right. So next up, we're going to take care of that negative 3. We want to make that a 0 as well. I'm hoping you see the strategy of putting some zeros in this to help yourself out. So here I got a 2 and a 3 I'm going to be combining with. So row 1, row 2. We're going to be writing on to row 2 this time. I forgot to change colors because life is golden. Let's do orange. So I want to use 3 and a 2, and I got to be careful to make sure my signs change correctly. So row 1 is the 3, so that means that one gets a 2. Row 2 is the 2, so that one's going to get the 3. And I'm going to add because this one's negative, and so I don't have to worry about the sign change. So this one's going to get a 2, this one's get a 3. Let's do this. Let's make sure we write in our first row because it's not going to change, and I don't want to accidentally write on it. It's another reason that it's a good idea to write that first, since I'm writing onto row 2. Let's add these two together. So this one's times 2. So that'll be... Ooh. Do I want to do that? Oh, I'm writing onto the wrong row. It's row 1 I want to write onto. This one's already correct. Whoops. I just realized I was going to do that wrong. That's a bad teacher. I fixed row 2 already. It's row 1 I got to worry about. Naughties. Okay. 2, nothing. 14. Good times. 2, 3, add together, nothing. 2 and 3, ew. So that's going to be 12 plus 2, that'll be 14. That's huge. Oh wait, this one's got a 14 too. That'll be okay. And then 7 times 3 is 21 plus nothing, 21. This is not the prettiest inverse I've ever seen, but it's doable. Let's do different colors so I can keep track of my operations. So here I need a 1 and it's a 14, so I'm going to do 1/14 of row 1 onto row 1. And here I have a 2 and I need a 1, so I'm going to do 1/2 row 2 onto row 2. And again, if you hate this, it's okay. So that'll be a 1. The reason why you do the zeros first is notice 0 divided by anything is still 0, so that's awesome. All right, here's where I got to get worried. Here's where I got to make sure I do everything correctly. So 14 divided by 14, 1. 21 divided by 14 is going to be 3/2, because, you know, they both have a factor of 7. 4 divided by 2 will give me a lovely 2. And then 7/2, that's just a beautiful number. So my inverse, ironically also in purple, didn't do that on purpose at all actually. 1, 3 over 2, 2, 7 over 2. That's lovely. And also doesn't fit very well, but you know, fraction action never gonna hurt nobody. Oh boy, I hate myself for saying that. Okay, so I'm hoping you've noticed a little bit of a pattern here happening with the matrices that are 2x2s. If you didn't, maybe you'll notice it now. Notice I have some sign changes that occur in certain places, and I end up always dividing by something very similar. And I'm hoping you notice that some things have also switched position on you. If not, here's a fun fact. So if you have a square 2x2 matrix, which I'm going to call the entries A, B, C, and D, we'll say that that's our matrix. When I do its inverse, it actually follows, let me put parentheses around this, a specific pattern. So read this as inverse of a 2x2 is always the following. All right, so I'm going to write this two ways because I'm worried you're not going to see it the first way. So you switch your diagonal. I know that sounds crazy. So D ends up here, A ends up here. You get the opposite of the other diagonal. So I end up with the negative of C and the negative of D. And then there, oh wait, not C, that's a B. Sorry. I'm having issues. And they're all divided by the same constant. So that constant is always AD minus BC. AD minus BC. AD minus BC, AD minus BC, AD minus BC. And usually when we do this, we write it a little cleaner. We'll do it like AD minus BC. So this is a second way to write this, with D minus B negative CA. Okay, so just to prove to you that that's exactly what happens, I'm going to go through and do this one, so you can see that it comes out the same, because we're hopefully going to be able to fit that on there. Yeah, you know what I'm trying to say, right? So for instance, if we took the matrix from, what was this, B? Yeah, B. From part B, and we did this to it. Let me change colors. So for example, we had the matrix 7, negative 3, negative 4, and then not minus 2, 2. And we did its inverse, and we got 1 over, so AC in this case would be so that'd be 7 times 2, minus negative 4 times negative 3, and then times the matrix, and here's where we got to be careful. You got to switch A and D, so switch the 2 and the 7, and then change the signs of both of these, and don't switch them. So 4 and 3. Okay, you multiply this out, you'll get 14, and then this is positive 12. So 14 minus 12 will give me 2. So this is 1/2 times that matrix, which, can I skip a step? No, I'm not that teacher. Not today, at least. So then we distribute in the 1/2. So 4 divided in half is going to be 2, and 2 divided in half is going to be 1. So 1, 2, 3 over 2, 7 over 2. Bam. Look at that. Is that the same thing we got earlier? Heck yeah, it is. Wish I could fit that all on one page, but I can't make this thing zoom out for some reason. Ooh, so we'll just flip back and forth until you guys are dizzy. I'm kidding. I'm not going to do that. Okay. I don't want to do the inverse of a 3 by 3 at all, actually. So I think I'm going to save these for the technology video. I really should do this. It's not that bad, but it kind of is. I did them in your notes, and I'm just like, don't wanna. Too long, didn't read, teacher style. Plus, I think I'm already at 40 minutes, and I've been trying to keep these to 40 minutes because I feel like that's a reasonable time frame. So, save me technology. Because, like, watching me do this with a 2 by 2 I think was a little painful. I don't know if you feel me on that one or not. Actually, I have no idea how you guys feel. Like, comment, subscribe. I'm just kidding. Tell me how you feel. Give me some feedback.